The next ones, we are simplifying the product and quotient involving square roots of a negative number. Way back many years ago, some guy named Euler decided that the square root of -1 would be equal to the imaginary number I. And if he could use an I in for the square root of -1, he could do a whole lot more math. Also then, going along with this, if I did the square root of -1 squared, squaring a square root would cancel that out, that would equal -1. Which means if I square here, I also have to square here. So I squared is going to equal -1. So when I'm working with imaginary numbers, anytime I have an I squared, I'm going to substitute a -1 in its spot. So I'm going to simplify some expressions that are going to have imaginary numbers. And so first thing I'm going to do is, if there's a negative under the square root, I'm going to take out the I. So I'm going to make this I square root of 56 and I square root of 7. Now, anything in front can be reduced, anything under the square root can be reduced together. So in this case, since I have an I over an I can cancel those out. 56 divided by 7 gives me 8. So now I have the square root of 8. I want to simplify my square root of 8 because I can simplify the square root of 8. So I'm going to make this the square root of 4 times 2. The square root of 4 is 2, and so 2 square root of 2 is going to be my answer in simplified form. Now in the next one, I'm going to make the first term I square root of 5, and the second one's just going to stay the square root of 2. Again, when I'm multiplying, I would multiply the two outside or front numbers together and the two things under the square roots together. And so I'm going to get I square root of 10. Now, if I could simplify the square root of 10, I would, but 10 doesn't have any factors that are perfect squares other than 1. And so I have to leave my answer as I square root of 10 because I can't simplify it any farther than that. Number 11 then, if I'm going to simplify that, same kind of thing, I would have I square root of 36 over I square root of 2. The i's are going to cancel. 36 divided by 2 gives me the square root of 18. I want to simplify my radical expression. 9 times 2 is 18, 9 being the biggest perfect square that divides into 18, and so I'm going to end up with 3 square root of 2. The next one here, I'm going to make that I square root of 20 times I square root of 5. I times I would give me I squared. Square root of 20 times 5, 100. Simplifying that, I squared is equal to -1. The square root of 100 is 10, so -1 times 10 would be -10. So number 12, if I'm going to simplify that one, I'm going to have I square root of 10 times I square root of 100 times I square root of 81. Now in this case, I could multiply first, but since my numbers are kind of big, since these are both perfect squares, I might just go ahead and do the square roots first instead of multiplying and having a great big huge number there. So the square root of 100 is 10, that would give me 10i. The square root of 81 is 9, so that would give me 9i. So 10i times 9i would be 90i squared. But again, we have to go ahead and substitute -1 in for I squared. And so I get 90 times -1, which is -90 for that answer. On the next one here, I'm going to have I square root of 90 over the square root of 5. That bottom one didn't have a negative. I've got to leave my I there, but I can reduce my square root down. If I take 90 divided by 5, I'm going to get 18. So I'm going to have I square root of 18. 18 can be simplified, so I would make that 9 times 2. Taking out the square root of 9, I get 3. So I'm going to have 3I square root of 2 for my answer. So simplifying those, I want to take out the I first, and then, like I said, you can either multiply or divide first, or if they're perfect squares, take the square root out first. It doesn't really matter as long as you're doing the math correctly.